Homestead Dairy has come a long way since 1979, when Floyd Huyen and his brother purchased a modest family farm in Plymouth, Indiana from their dad. At the time, they were milking 110 cows. Today, the dairy numbers 1,800 milking cows and 300 dry cows, while milking another 1,700 cows at 3 other nearby facilities. Plans call for expansion within the next 5 years. But more cows means more odor emanating from the dairy, which impacts neighboring residents. To lessen the impact of the odor from cow manure, Homestead Dairy developed a waste-to-energy facility that takes a steady stream of manure and converts it into electric power.
We're able to capture the gas, which if we weren't running it through this system, is normally just goes up into the air. And that's part of the odor that the neighbors will, we haven't had a lot of neighbors complain about it, but it gets, I can tell it's there, so I know they can tell it's there. Sure. Well, this will help eliminate a lot of that.
In October 2013, the dairy began producing 1 megawatt of electricity from a waste stream that is piped more than a quarter mile to a new facility called Homestead Green Energy. The animal waste is fed into 2 mixing tanks, then pumped into 2 complete mix anaerobic digesters, which convert it to methane gas. Gas from the digesters powers 2 Caterpillar G3512 generator sets. Electric power produced by the generators is sold back to Northern Indiana Public Service Company, or NIPSCO.
It'd be another income source. We got a 15-year contract with NIPSCO to supply the power, and the plan is as we grow the dairy operation, we'll put in another gen set.
It's driven to make money. I mean, that's what we're doing it for. We wouldn't be doing it if it didn't make money, but it also helps the environment for your nutrient values. The crops use the manure better, the odor reduction for the community is a large benefit, but to make money is the key.
When Huyen looked at several other farm renewable energy facilities, he determined that Cat gensets were his best choice.
We looked at their installation, talked to the guy that has to take care of it. They had foreign-made engines, and everybody that had the foreign-made engines, their common complaint was parts availability and cost.
Parts availability and service were major considerations for Huyen.
It's going to need service, so you got to have parts and service available. We can't afford the downtime.
When the gensets were due for their first oil change, Rogers required some help servicing the valves.
I called up the dealer. Next day, we're down here, no questions asked, very helpful, great people, and got in and got out. They understand that it's got to be running, not sitting.
Huyen was inspired by the large-scale agricultural sustainability he saw at another farm in northern Indiana. Many are hopeful that farms across the country will adopt sustainable production practices, thereby reducing fuel costs and pollution.
Yes, I could see many dairies taking advantage of a resource that they have and turning it from a liability, from a pollution or odor stance into a valuable resource for the community. And I do believe that there's great benefit for the dairy community in an installation like this.
Caterpillar has been building generator sets and engines capable of burning renewable gas fuels since the 1960s.
Got a rich history in it, a tremendous amount of assets out in the field, as well as our dealer organization is set up as a local avenue for parts and service. I think you'll find that the Caterpillar dealer network has a service organization that's unmatched.
We are in a race. The race is against time.
We have to build cities. We need them, but we have to make them in a different way.
We need a wave of innovation, not only for our way of life, but also the planet.
The consequences would be enormous if we lose this battle.
I'm Thomas Getz, executive editor at Wired Magazine. At Wired, we look at the innovators and innovations that are changing our world. In the next hour, we'll see 3 stories from acclaimed filmmakers about the future of energy. We'll explore cutting-edge innovations in how we drive, how we live, and in our first story, how we fuel our cars. They are all ideas that promise to shape the path to the world of 2050.
The world has right now close to 1 billion cars, and we might double the number of cars on the planet by 2050. So if we double the number of vehicles, we really increase the amount of fuel they consume, and that's going to have a big footprint in terms of our demand for resources to move all those vehicles around.
We're pulling up carbon that's been stored underground and burning it in our automobiles and putting all that carbon dioxide into the atmosphere. If we don't reduce that, we could have changes in the climate that we could never recover from.
There's a number of forecasts for what type of transportation economy we could move into. One vision is that we will use more and more liquid fuels. Another one is we'll use more and more electricity. And right now, more of the industrial activity is focused around liquid biofuels.
The thing about a fuel is it's really unparalleled on a weight basis how much energy is in a gallon of fuel. And even if batteries develop as some of the advocates hope they develop, we're not going to see batteries running large trucks, and we're certainly not going to see an electrified air fleet. We're going to need transportation fuels for those that will directly replace the petroleum-based fuels that we're using today.
This has kicked off people looking at a whole range of other alternatives to petroleum in your tank.
Commercial production of ethanol as fuel started in Brazil in 1975. When we started the ethanol program, nobody talked about reducing emissions. This was not an issue at that time. First, and most important, we didn't have money to buy oil anymore after the first oil shock. We were importers of oil. And today, more than 50% of all cars use ethanol instead of gasoline.
Brazil made a very conscious choice to try to find a way to reduce their fossil fuel dependence. And they didn't have to look very far because Brazil's climate is ideal for growing sugarcane.
When you have sugarcane plantation, you have only 2 things to make, sugar and ethanol. My family has been in sugarcane business since 1955. And about 30 years ago, I thought there is opportunity to make more ethanol. And now we are producing 120,000 cubic meters of ethanol.
Brazil today has very close to 400 sugar mills. The overall sales is $30 billion US dollars, and this number is increasing.
If you look at how they make ethanol and how efficient the process is, it's really a model for all of us. They grind the plant up, extract the sugar from the cane. The sugar goes into these large fermentation tanks, which combines sugars together with yeast that naturally produces ethanol. They use the rest of the plant to generate heat to distill the ethanol and turn it into fuel. They also use that heat to generate electricity renewably, not putting excess carbon dioxide in the atmosphere.
Brazil has gotten to a point today where they're using about 40% less petroleum than they would be otherwise. But Brazil cannot supply the whole world with ethanol because they would have to cut very strongly into food production and into critical natural areas like the Amazon to make that happen. And this really boils down to the fact that there's only so much arable land, and growing fuel for our gas tanks is yet another demand on that landscape.
We cannot kid ourselves in thinking that we found a general solution for the world problems. I think we will have to face the world in this way today. We have no oil in very large quantities anymore. We have no coal transformed in a clean way. In the meantime, we have to do the best we can. And the best at the moment is that they can do biofuels.
Sugarcane to ethanol is an incredibly efficient process. You get out about 7 times the energy you put into growing the sugarcane. In the US, when we produce ethanol from corn, for every unit of input of energy, we get about the same amount of energy out. So we're really not gaining anything. We need a better process. We don't have to take what nature's given us. We can actually engineer plants and yeast to be more efficient, and that's the basis for a lot of the work that we're doing now.
What we need to look at, though, is which of the pathways that come out of this are not only good financially, but those that are also good in sustainability. And this equation is really wide open right now.
We are in a race to develop fuels. The race isn't with other countries, the race is against time.
To meet the immediate and future demands, we made the energy solution spring from the ground.
Brazil is the most efficient ethanol-producing country in the world. Sugarcane alcohol from Brazil can reduce the total carbon footprint by up to 70% compared with the gasoline.
The biggest challenge for fuel providers and car manufacturers is to reduce CO2 emissions over the next 20 years.
Demand for mobility will continue to grow. We believe that biofuels are very important because they help in an immediate way. All forms of fuel are going to be needed. Hydrocarbons, natural gas, biofuels, all of them are going to be part of the energy mix for the future of transportation.
Brazil has been very successful at taking a resource they had and finding the process to make that into ethanol. And people call those first-generation biofuels. We have lots of lab work around the world that are looking at the second generation. That's generally turning cellulosic material from, for example, weeds into biofuels. And the United States is very much at the forefront of the innovation part of the equation.
For centuries, we have been using yeast to consume glucose and produce wine and beer. We're trying to do something very similar, only we're engineering the yeast to consume that glucose and turn it into a fuel or a drug or chemical. We call this synthetic biology. And when I started in this area, many of my colleagues said, "Oh, Jay, this is great work, but where's the application? What are you going to do with these tools? Who cares?" Malaria is an enormous problem. In any one year, 1 million or so people die of the disease, and most of them are children under the age of 5. So we thought this was a great opportunity to engineer yeast to produce an anti-malarial drug called artemisinin. This drug is derived from plants right now, but it's too expensive for people in the developing world. So my laboratory engineered yeast to produce small quantities of artemisinin. Now that process is being scaled up and we'll have this drug on the market shortly, but at a substantially reduced cost. It turns out that anti-malarial drug is a hydrocarbon, and it's very similar in many ways to diesel fuel. We thought, gosh, we could turn our attention now to fuels. We could make a few changes in that microbe to turn it into a fuel-producing microbe. If we imagine that glucose is going to be our new petroleum, we need a source for that glucose. And so the crops that we're looking at are crops like switchgrass. This is a native grass that grows without a lot of water and on marginal lands that we could turn into energy farms. The challenge, though, is that unlike sugarcane, it's very difficult to get the sugar out of that biomass. So we use what we call a pretreatment process to extract the glucose from the plant, and then we feed that glucose to a yeast that we've engineered to produce hydrocarbons. And that yeast takes in the sugar, and it changes its composition and gives us this high-energy molecule. They float to the top, you skim them off, you put them in your tank. But it takes a lot of work to get from that small test tube all the way up into the million-gallon tank. So we have to give it time, but I think that some of the discoveries that are happening might be applied by the end of the decade.
In terms of a sustainable equation for the planet, the role of biofuels is quite tricky. There are a variety of crops that do not compete directly with food, and finding ways to utilize those types of crops first, that's very attractive. So solving the science is part of the story, but then evaluating all of these new fuels in terms of the land use impacts that they could have, that is an even harder story than doing the good science.
Imagine that you could have one process that could take in sunlight and carbon dioxide and turn it into fuel. And imagine if that didn't involve growing anything at all.
The synthetic biologists are trying to take plants and make them do things that they wouldn't normally do. On the other hand, materials chemists like myself want to do artificial photosynthesis to improve on the process that nature does in real photosynthesis. We should follow the blueprint of plants converting sunlight into fuel, but take the approach that it could be much simpler. All we really need is a light absorber that absorbs sunlight. We also need a catalyst like iron or nickel. So when you see the hydrogen coming off of the photoactive material, that's an example of a semiconductor breaking the chemical bonds of water to make hydrogen and oxygen. Ultimately, our pieces are going to be contained in something that is easy to roll out like bubble wrap, where in would come sunlight and water. You would vent the oxygen to the air, but the bottom would wick out your liquid or gaseous fuel that then you could collect and use for our cars and planes and storage. Our goal is within 2 years to have the first artificial photosynthesis solar fuels generator that we can hold in our hands, and then get to scale beyond that time.
We're certainly not good at predicting the future, but to me, electric vehicles look like a sustainable option. We've heard proposals about things as far-fetched as nuclear power planes, and even some proposals to move freight around with lighter than air vehicles. And so, if the future in 2050 does include a fair amount of oil, what it means would be that we haven't deployed as many of these clean technologies as we already know are possible.
If you think about how long it's taken for us to build up the petroleum industry, we can't hope to reverse that overnight. It's a huge change in our infrastructure. Yes, we should have been working on it 30 years ago. We didn't. We're trying to make up for that, and that means basic research needs to be done now and by as many people as possible. We have a long way to go, but I'm confident that we'll get there.
In the future, 3D maps are going to help people get places more efficiently.
As we just saw, the race to produce cleaner energy is charging ahead. In the meantime, demand for cars continues to climb. By 2050, it's predicted there'll be 2 billion cars on the planet, and fuel consumption will have tripled. To keep pace, we'll have to radically change the way we drive. Here's our next story, Driven by Design.
The automobile came around. In many ways, it was the future. We thought of it as one of the more positive changes that had happened to society. Suddenly, our ability to get a job changed. We can live farther away with bigger plots of land, with better quality of living. It all looked quite good. But there are limitations to swearing by the car. If it gets congested, your quality of life drops immediately. To spend so long in the car, it's very inefficient use of fuel consumption. Things stop making sense all of a sudden. It doesn't bring you closer to where you want to get. It actually sometimes brings you farther.
The average American spends nearly 300 hours a year in their car, 38 of them stuck in traffic. Annually, congestion consumes over $1 billion in gasoline in the United States alone. The inefficiency caused by traffic, both financial and personal, is enormous. Dirk Sheehan and Carmen White's story is not that unusual today.
Dirk works an hour and a half away in Warrenville, Illinois. Generally, he wouldn't leave work until 6 or 6:30, and I would say usual time for him to get home is around 8.
Usually when I wake up, I'm the only one up. Sometimes the kids wake up with my routine. More often than not, I don't see them in the morning. I think about my commute when I wake up. I check the traffic report, see if there's any delays. The worst case scenario, it takes me 2 hours to get to work.
We are already so limited in the amount of time he can spend with the kids. And our expenses are crazy high. We are spending $400 a month on gas. It takes away from our food budget, and we never paid for gas like that before, ever.
If there's technology that would allow me to spend less time in the car, spend less money on gas, and spend more time at home, I'd be all for that.
The cost of traffic is people's time, it's fuel wasted, it's an emotional toll, it's a frustration. Utilizing the roads more intelligently is a much more efficient approach to the inability to have supply keep up with traffic demand.
If you took a satellite picture of the highway, you can see that there's actually a lot of open space. And if we had the technology for cars to drive more closely but safely, then you could increase the utilization of the road network.
What this means is that to be more efficient, to use less fuel, we need to see the road differently. We need cars that can navigate through the urban landscape in a radically different way.
Maps in the future are going to be able to help people get places either more safely or more efficiently. Today, it just helps you get from point A to point B. But what if I want to get someplace and use the least amount of fuel possible? Or if I've got a hybrid vehicle, I want to make sure I've got plenty of charge, not only get there, but to get back home. So information that is going to help people achieve the more efficient or the safer route is more detailed information about the road than a lot of people realize is possible to collect today.
Here in Chicago, Nokia's Location and Commerce Unit is developing the next generation of mapping. LiDAR, sonar, 360-degree video, all are components of what Nokia calls digital mapping.
We use 64 lasers that rotate and they collect data in a 3D way about the world. It creates what we call a point cloud of information. That point cloud allows us to measure distances then between the points that we collect. That system combined with the cameras with higher precision location detection through inertial measurement units, that whole data system allows us to collect 1.3 million points of data per second. Probably within 2 to 3 years, you're going to see 3D maps that are going to integrate the traffic information into your routing to help you understand. If I've got 5 different routes to take, which one is the most efficient today, given the way the stoplights are running, given the way traffic is running?
All of those factors are going to be taken into consideration to make sure I've got the best route.
But better mapping that can integrate topography, infrastructure, and density is only part of the answer. Another key to improving transport efficiency is building cars that drive themselves.
Autonomous vehicle technology has a tremendous potential to improve efficiency of our road infrastructure.
By removing humans from the equation, we eliminate all the things we do wrong behind the wheel. Speeding, changing lanes too often, merging haphazardly. And by marrying autonomous vehicles with sophisticated 3D maps, we can make driving safer and more energy efficient. That next generation vehicle is being built right now by the Swedish trucking company, Scania.
The solution, as you see it, is that the vehicles can utilize intelligent maps, three-dimensional maps with traffic information. The vehicles will be intelligent and communicate with each other. They will talk to each other, they will talk to the infrastructure. And we will see completely autonomous driven vehicles.
The goal was to have multiple robots and see if they could go 60 miles fully autonomously.
When your healthcare facility chooses CAT power generation equipment, we give you the kind of confidence that is unshakable, even if there's an earthquake. And now we're making it easier to meet state mandates requiring your hospital to ensure that it will continue functioning during and after a seismic event. The California Office of Statewide Health Planning and Development, OSHPD, allows equipment manufacturers to conduct shake table tests on representative units. Once a generator model has passed certification, the actual unit being delivered to your healthcare facility does not have to undergo an individual shake test. What does that mean for your facility? Faster installation and commissioning, which can greatly reduce your time and costs. Independent shake testing on CAT generators was conducted at the Caltrans Seismic Response Modification Device Test Facility at the University of California, San Diego. Following this test, CAT equipment received special seismic certification pre-approval from OSHPD at a design spectral response acceleration parameter level of 2.1 G SDS, which far exceeds the minimum SDS of 1.93 G required. No other supplier has achieved seismic ratings for the large power nodes higher than CAT. A full range of CAT generator sets, providing power from 650 kilowatt to 3.1 megawatt, received special seismic certification pre-approval from OSHPD. With a pre-approved CAT generator set, you save time and money, and gain peace of mind for your healthcare project. You'll have the most trusted name in power generation on your side, providing higher certified power outputs than anyone else can deliver. Now that's a fair shake.